Okay, nice. I can record. So, Nicholas, it has some things that we just can't differentiate. Kind of hard to differentiate. So, what we need to do is we need to split it up into two composite functions, both which we could easily differentiate. So, we reached we did 1 and 2 last class, right? 1 and 2?
Yeah.
We didn't do 3. We did do 3. Check your notes. Amy, no, I can't ask you. Amy, I can't ask you because I can finish this. Yeah. Nicholas, check the very, very last thing you did. I trust how you take notes in class.
Yeah. I just have to pull out the book.
You don't have a book yet?
Nah,
It's kinda crazy.
no, yet I'll think. Um, last thing was the um
Was it the leg? Because you said you don't get a joke.
the
That's stupid. You said right? He was like yeah, then that was the other thing. And I was like, because he said he's like
yeah.
anyways. 1, 2, 3, 4. We do up to
I think the last thing I list upon was 1 because I have the dates in my book. And it's saying that, like, when we had the class on Sunday, we did the second one.
oh,
Yeah.
okay.
So I just do 1 alone.
All right. Well, let's recap. All right. So we looked at if you have y is equal to sine 2x. I'm gonna do all these cases as a matter of fact. Just to make sure they fully understand it. I'm just gonna speed through the sine 2x though. Add page after current template. So these are all the cases you will get at this level. So Nicholas, let me do a question. Y is equal to sine 2x one time. But let me do a kind of inspired question. Let me just say y is equal to sine minus 3x. Let me change up things. So we did this last class. You should be able to handle it. So tell me, Nicholas, can we differentiate sine x? Sine x. Sine x by itself.
Yeah.
The problem is I have minus 3x. We don't know how to differentiate sine minus 3x. So if you was to define this using two smaller functions, you would have say that f of x is equal to what?
F of x is equal to
Be careful though.
alright, so we mean minus cos is
No. F of x, which would be the main function, would be 2 sine x. And what would g of x be then?
g of x differentiating that.
No. I see you forget a little bit.
Yeah.
But
Right now a little
like you party
kinda
too.
huh?
You party as well.
No, I just a little sick.
Oh, okay. So, Nicholas, the
Mm.
problem is we don't know how to differentiate minus sine minus 3x. So what we're gonna do is we're gonna split it up into two functions. Watch. I'm gonna say f of x is 2 sine x, and I'm gonna say g of x is minus 3x. So if I plug g of x into this, what am I gonna get? If I replace the x here for minus 3x, what am I gonna get?
2 sine minus 3x.
And that's the original thing.
Yeah.
Let me ask you that question. Could I differentiate 2 sine x?
Yeah.
What's 2 sine x if I differentiate it?
Minus 2 cos x.
No, if you differentiate sine, you get cos. So it'll be 2 cos x, right? And if I
Yeah.
differentiate minus 3x, what do I get?
Minus 3.
So is it that we can differentiate both of those things?
Yeah.
Right. Now, the f of x and the g of x method, that's the proper method. And that's one way you could think about it. The other way you could think about it is you could simplify. So what caused in trouble in this question? Again, we know how to differentiate sine x. So what caused any trouble in this question? If
So
it,
it's
if it was sine x, we'd have differentiate that easy. What's causing trouble?
minus 3x.
Right. So what are we gonna say, right? We're going to say, let u be equal to minus 3x. If u is equal to minus 3x, what would y be equal to? So Nicholas, we're saying that minus 3x, this whole thing is u. So that would make y equal to?
2 sine minus 3x.
No. Again, we're saying u is equal to minus 3x. So anywhere you see minus 3x, we're gonna replace it for u now. So y would be equal to?
2 sine u.
Correct. Now, we have u with respect to x. So if I differentiate this, I'm going to write d what over d what?
Du over dy over du.
Okay, where you get y from?
I mean, du over dy.
Where you get y from? This is u with respect to x.
Oh, du over dx.
Du over dx, yes. You have to be careful of that. So a good thing I review this. And if we differentiate minus 3x, what will you get?
Minus 3.
Awesome. Now look at the variables here, right? We have y and we have u. So that'll be d what over d what?
dy over du.
dy over du, correct. We're differentiating y with respect to u. So dy du. And if I differentiate 2 sine u, what do I get?
Um, 2 cos u.
2 cos u, excellent. If you recall, at the very start, we had y is equal to sine minus 3x. Y is equal to 2 sine minus 3x. So we really wanted to differentiate y with respect to?
With respect to x.
Right, so we still need to figure that out. We still do. So I'm going to use a chain rule now. And a chain rule is when you link together two different rates of change. And you can understand that this is u with respect to x, and this is y with respect to u. And both of them different, and both of them different from dy dx.
Yeah.
But we could combine them. So what would I have to do with du dx and dy du to get dy dx?
Um,
See if you remember that.
yeah, just cancel out the du in the
Correct.
numerator.
So you're saying we had to multiply the two different rates of change. And that was in? To
Yeah.
multiply them, right? Yeah, that's exactly it. We have to multiply them. So dy over du, multiply by the du over dx. Right. So dy du is what?
dy du is 2 cos u.
So we're going to multiply that by?
Du dx, which is minus 3.
Right. So I'm going to change that to 2 cos minus 3u. So that's correct. Is it right for me to say that?
Um, yeah, I think so.
No. We're multiplying this whole thing by minus 3. So what should it be?
Then it will be minus 3 by 2 cos u.
It's minus 3 by 2,
minus 6.
right?
Plus
And one thing, our final answer cannot have u in it because dy dx. So what did we say u was from the start?
u was minus 3x.
Right, so we're going to say minus 6 cos minus 3x. Lovely. Do you comprehend?
Yes, I comprehend.
Nice. So that was the long method. Let's look at the shortcut method because there's a much shorter way to do a question like this. All right, but it depends on how they ask the question. If it's a pure chain rule question, you need to do the full working. If it's part of like a quotient or a product, then don't do the full working. But I'm just gonna show you the shortcut anyways. All right. So Nicholas, do you recall the shortcut method?
Probably after I see a part of it, then yeah.
All right, let me go up to the previous notes. All right. So I want you to notice if you see a pattern, right? So if we differentiate sine 2x, you get 2 cos 2x. If you differentiate cos 5x, you get minus 5 sine 5x. And this is what the shortcut says. Really shortcut.
Differentiate inside and multiply. Differentiate the check function, leaving the term inside.
Right, so watch. How do we go from sine 2x to 2 cos 2x? So really shortcut. Differentiate the inside. So if I differentiate 2x, what would I get? 2, right? And I multiply it. So I say 2, I put 2 in front, and then I differentiate the trig function. If I differentiate sine, I'll get,
Plus
right? And then I write back what I had on the inside. So you're differentiating the inside and you're multiplying, and then you're differentiating and you're writing back the original thing. So let's apply those steps here. So I want you to differentiate the inside. Was it if I differentiate the inside here, where it go be?
just minus 3 alone.
Right, but I'm multiplying, so I'm in the minus 3 on the outside. They're gonna multiply by the 2 on the outside. If I differentiate sine, what I get?
Plus
Right? So I'll change any sign to cos, and I'm gonna write back what was on the inside, minus 3x. Where's minus 3 right to?
minus 6.
Did we get the same answer?
Yeah.
Yeah. Nice.
Yeah.
Yeah. Amy, you remember all this stuff?
Yeah.
Nice. So let me give you all a question. So let me just say we have y is equal to a half. Nah, let me make things interesting. Y is equal to minus a half cos 7x. Try that one. So I give it all you 5 minutes for that one. Take 5 minutes and do that. Right. Let me just take off my mic. All right, guys. So the time kind of up, eh? Don't really see that, but the time is up. Yeah. Alia, I didn't even know he was in class. Hello. Good morning.
Hi,
How are you?
I okay.
That's good. That's good. Long time I see you. So much like I didn't see you yesterday.
Yeah,
Um, is Kira in class? I can't see.
yeah.
Okay, Kira. Good morning, Kira.
Hello.
You know how you say that just now? It's only meme. Your phone is ringing. You say it like that. You said hello
Oh
like that.
Lord, no way.
Yeah. Look back at the recording, you'll see what I mean. But anyways, as you come into class today, would you have done differentiation in class and like your regular class like at school?
Yep. But he like, to be honest, like with this topic and the differentiation that topic, he raw Russian, like he literally like raw Russian through it. So I kinda relying on lessons to teach me how to do it properly. Because I don't know how to explain it, but basically like he will come in class, do a question, and then be like, okay, so we starting this new topic next day.
Hmm. Sound like some halfway man behavior. Right. No worry. I'll explain it later. Yeah, you kinda up to speed with what we're doing so far. Like this is chain rule.
I know I did the question, I said I working now.
Okay. So you understand the shortcut method and the long method.
Yeah, that's to an extent. Yeah, I guess. Yeah.
Well, I don't know if you was there when I told the class the chain rule is when you got something complicated and you have to split it into like two simpler cases. So obviously we don't know how to differentiate my sine minus 3x, but we know how to differentiate sine x, and you know how to differentiate sine x?
Yep.
If I differentiate sine x, what am I gonna get? If you say yes, you have to tell me now. If I
I know
differentiate,
I was gonna talk.
if I differentiate sine x,
And like, many differences in the cause. I don't
yeah,
know.
it will turn to cos x. Nice. Um, so we know how to differentiate sine x. Do we know how to differentiate? So if I simplifying this, right, and I'm saying let u be minus 3x, what that means is this whole thing here gonna become u. So now y is equal to 2 sine u. You understand?
Yeah.
Now, by me doing that, I have two different rates of change, meaning that I have du dx and I have dy du. And both of them different from dy dx.
Yeah.
Well, I can multiply them and we're going to end up with. I'll multiply them.
dy dx equals to.
Yeah, I'll get dy dx because the du and the du cancel off, and I'll get dy over dx. That's always work. Did you know that before?
Yeah.
Okay, cool. So the first step is to let some expression or some term be equal to a variable. We're gonna say let this be equal to u. You think you could understand why we letting this be equal to u specifically?
Yes.
Because if I make that u, right, and now it would now become y is equal to, what would it now become?
2 sine
2 sine 1.
x.
No, what we saying minus 3x is equal to.
Oh, u.
Yeah, so we might make 2 sine u. You understand that now?
Yeah.
And can we differentiate minus 3x?
Yes.
Right? Cool. Could we differentiate 2 sine u?
Yeah.
Yeah, so that's the goal. The goal was to simplify it and break it down into into expressions, we could differentiate and then combine them by using the chain rule, right? This is the chain rule, multiplying two different rates of change, and you get your answer. Anything over here confuse you? So I missed anything?
No.
No? All right. Aliyah, I think they're working from you.
I'm gonna send it now.
Whoa, you sound kind of sick there.
Yeah, make sure it's still kinda
Kind of destroyed.
yeah.
Aliyah, how I sound? That's a question I'd
You
ask.
just like a mashup.
Boy, if I tell you, I was screaming at the top of my lungs, yes. When the goat come out, when the chief come out, hey. But guess what though? Guess what, Aliyah? You wouldn't believe this.
What?
I didn't drink a single alcoholic beverage last night. I ain't even lying. I ain't even lying.
I don't believe that.
No, I'm serious. Like I'm actually serious. I did not. It's crazy. The event was just good. So I didn't have to do that.
Unbelievable.
I'm not like Bryson.
Bryce and Sasha. Yeah.
Yeah, not like them. I can enjoy myself while being sober. You don't need to be drunk,
Good, yeah.
right? Lessons for the youth. Youths, always the youths. You don't need to drink to have fun.
I don't know if my answer correct, but
Let me
like
check it out.
I know what to do.
So most of they could probably figure out the answer using a shortcut method. That's okay. If you if you forget how to do it the long way and you remember the shortcut method, chances are you'll still get 2 marks out of the 3 marks. Okay, yeah, I see in some trouble. Let me rectify that. So Kiera, I want you to stay unmuted, right? Kiera, stay unmuted.
Why?
Y is equal to 2 sine minus 3x. Why? Because you need to understand the thing, right?
Yeah.
And the only way you gonna understand it is if I push out of your comfort zone and you have to, forced to answer. Because otherwise, you're gonna be in bed sleeping, eating.
I'm not.
I know your antics, you know, Kiera, but you have potential. So let me exploit the potential. So let me do it using a shortcut method first, right? Kiera, walk them through the shortcut method, and Aliyah, pay attention to the shortcut method. Yeah, tell them, Kiera.
So basically we have y equals to a half cos and in brackets 7x, and then we put dy dx equal to, we put in the, it's got a variable
So dy dx, that means we're differentiating y with respect to,
x.
right? So that means jumping straight to the answer. Okay, what next?
Okay, so in brackets you're gonna put 7, that is from the 7x.
Right, you differentiate the 7x.
You differentiate the 7x, and then you're gonna differentiate the negative a half cos. So it'll
No,
be,
no, it don't work like that. The minus a half is being multiplied by cos. It don't have anything to do with cos. It's just being multiplied by it. So you're gonna write back 7. You're gonna put 7, and you're gonna put back the minus a half. Right? You're gonna differentiate cos now. If I differentiate cos, what will we?
you will get sine.
No, a minus sign.
No, I thought it. Oh yeah.
Right? And then I'm gonna put back the 7x. Right? So if you multiply this out, Aliyah, what is 7 by minus a half by minus? So we have 7 by minus a half by minus. What will that work out to be?
You got +7 over 2.
Yeah. You see that real unsure, but it's real simple actually. And then I was just gonna write back sine 7x. That's it.
That's
That's
it.
just that's a shortcut method. So in the shortcut method, I'll lay out what, right? In the shortcut method, you're gonna differentiate the inside, right?
Right.
Then you're gonna multiply whatever you have in front by that. So 7 by minus a half is minus 7 over 2. Then you're gonna differentiate this. If you differentiate cos, you're gonna get minus sign. So well, the minus by the minus would be a plus, and that's how it work out. Real easy, right?
Yeah.
I think everybody in the exam, if they forget the long method, they could do the shortcut and get at least 2 marks. Right. So this is the shortcut method. Let's do the long way now. So Kiara, in this equation, what's causing real trouble? What's causing you trouble in that question?
The if you hear anything in the background, I see it.
That's okay.
The negative.
Again, no, that causing no problem. Remind me, according to the tricks you learn, we could differentiate. You can differentiate sine x on,
What was that?
right? What making this not look like cos x? What making it look a little strange? Because you know how to differentiate cos x. You don't know how to differentiate this though.
You
You know how
said
to yeah, we don't know how to differentiate cos 7x. We know how to differentiate cos x. So we need to do something about that. See, CD 7x here, it causing some trouble. So we're gonna say let u be equal to 7x. So Aliyah and Kiara, if I say u is equal to 7x, that means this whole thing now is u. So what would I write next? What would y become?
y will be equal to minus sign
No, minus a half.
minus a half sign.
Where you get sign from?
And what is it? Minus a half sign.
Take your time. Wait, we didn't do any differentiation yet. All we said was u is equal to 7x. So this is u now. This is now u. So y is equal to
Minus a half.
continue. Is exactly what you see in there.
Minus a half because you.
Yeah, that's it. Watch. All we did was we saying 7x is u. So now instead of 7x there, it have a u. Aliyah, you understand now?
Yeah.
Yeah.
Kiara, do you really understand now?
Yeah.
Okay, cool. Because I don't want you to tell me you understand something and you're feeling a little icky about it.
No, I understand. I just have a hard time explaining how to do work and just.
I see. Well, we work on that. So, Kiara, do we have 2 different equations now?
Yeah.
Are these equations workable though? Could we differentiate them?
Yeah.
All right, the first one. Tell me what to write. We differentiate and what with respect to what? How is that working out?
You're differentiating y, which is
Okay, tell me where you get y from? We differentiating the u
we're differentiating u
with respect to
x.
right because it is u equals 7x. So that'll be du dx. That'll be equal to
7
right.
because
Now look carefully over here. This one is y and this one is u. So y is in terms of u. So how are we gonna write that?
dy over du.
Yeah, right? And if I differentiate minus a half cos u, how are I gonna work out?
It will be
So the minus a half, that's just a number, right? That's a number that in front. Don't bother with that.
Okay.
Let's differentiate because for differentiate cos u, all get
Minus sine u.
minus sine u, yes. And let's go work out to be what? If minus a half by minus.
A positive.
Positive a half. So we have dy du and we have du dx. So now we need to find dy dx. How am I gonna find dy dx? Tell me, Kira, I want you to look at dy du dx and
Multiply.
multiply, yeah. And what two things will cancel off?
The du's.
Yeah, the du's. You can see it. So we'll end up with dy du, which is a half sine u multiplied by du dx, which is 7. So what I'll work out to be, Kira?
It will be well. My answer was
Wait, forget your answer. We're looking at this thing on the screen right now. You need to move forward. How are we gonna move forward? I have a question.
yeah.
Is he next line that or is he next line that? One or two?
The second one.
Yeah, it's the second one. So how come you didn't tell me that? Hmm.
Mm,
So it will be 7/2 sine u. And alas, we're at the final stage, but we still have u in our answer. We can't have that because it's dy dx. It's y in terms of x. We're not supposed to have any u. So Kiara, did we say u is equal to anything at the start?
yeah.
Or u is equal to at the start?
7x.
Right? So you're going to end up with 7/2 sine 7x. That's it. So all of you guys need to copy down the full working. And that's it there. We understand the shortcut. But now
Yeah.
you need to understand the long method. Let's copy that down. Amy, since you finished with these kind of questions, right? I want you to try this one. Try to differentiate 5x squared sine minus a half x. Yeah, Amy, try to differentiate this. If anybody brave and they understand everything we did on the screen already, and I just wasted all the time, or they could do something all the time and try this one here. Y is equal to 5x squared sine minus a half x. It's not just a straightforward question. You need to think about it. If you feel like you can't handle this question here, that's okay. We're working my way towards it. Don't be too startled. Optional. So Amy, you're working on the optional question.
Yeah.
All right. So Amy, in this question, you gonna do the long method or the short method for the chain rule?
I will do the long method.
The long method,
Well,
what? I don't matter, you know. It's just gonna take up more time.
okay.
But typically, we don't use the long method if it's involved in something like product rule or quotient rule. And this is what question. Were you able to recognize that this is product rule?
You know.
No.
Mm-mm.
But
Now,
now I can mention it, I can see it.
the reason why, okay, if the x squared wasn't there, then it would have be chain rule. But you have an expression multiplied by an expression. And this is our polynomial and this is our trig.
Yeah.
Yeah, they're two different things. Both of them have x in it, and they're being multiplied. So you can't just say is chain rule. It's not. So as soon as you all have the full working copy down, let me know, and we'll move forward. Kira, do you actually understand the chain rule now?
Yeah.
Now this is the same, no matter what how it looks, it's the same concept. You need to simplify something. You see how we could not differentiate cos 7x? Well, you needed to let it be equal to something simpler. So like u. We're gonna use that right through, no matter how it looks like. So you have it copied down?
Yeah.
All right. Alia, you have it copied down?
Yeah.
All right. Nicholas, what about you?
Yeah.
All right. Oh guys, I can't see anybody who's in class. And on my laptop. Is Kirsten in class?
Yeah.
Okay. Kirsten, um, again, I can't see the chat, so you gotta message me privately on WhatsApp, right? Message me on WhatsApp if you want me to go over anything, if you need help with anything. Or just message if you need help with anything. Cool. Let's move forward now. So we looked at case one. Again, all of this was case one. All we did here, this was case one, right? This is case one. Let's look at case two now. Now, case two and case three is more or less the same thing. These two are more or less the same. Well, here what? If we only topic at trigs one time, let we just do 4. So let me just reverse the order of this thing real quick. Let me do that. Why not? All right, so the next thing we're going to look at is what's going to happen if we're squaring a trigonometric term. What if we're cubing it? All right, so that's the next case we're going to look at. Case 2. So what if we have something like y is equal to sine squared x? Kira, is that the same thing as sine x? Remember, sine x is the only thing we actually know how to differentiate it. Does that look like sine x?
No.
No. Problems. Aliyah, what does sine squared x mean?
Sine by sine.
Right. That means sine x by sine x. Another way I could write that if I wanted was sine x squared. Maybe I might see it better like this.
Yeah.
This and this mean the exact same thing. So Kira, if you're confused, just know that in maths, this is just a notation fair. Like this is a notation, right? This over here is a notation for this. So sine squared x really means sine x by sine x, which is sine x all squared. Do you comprehend? Don't you with me? Kira, you locked in?
Yeah.
Okay, so Kira, I have a question. If I had sine cube x, what's that?
Sine x by cube
Say that again?
bracket sine x and then cube.
Yeah, that's correct. And it also means sine x by sine x by sine x.
Yeah.
Cool. Good. Once you understand that. So, Kiara, again, if it was just sine x, we could have differentiated that real easy, right?
Yeah.
Okay. But it's sine x squared. Ah. We don't know how to differentiate sine x squared, right? That we don't know how to do that. You think we could differentiate x squared though? You know how to differentiate x squared? Yes or no? Simple question. You know how to differentiate something like x squared. Like if you had x squared. If I differentiate that, where you go?
I think so.
It's like first days of differentiation. I'll be 2x.
Yep.
If I differentiate x to the power 7, what I'll be?
7x.
Awesome. So, Kira, in the in the last example, we had let u be equal to the thing that was inside the brackets. We're gonna use the same thing over here, right? Because we don't know how to differentiate sine x star power, and we know how to differentiate like x star power though, and we know that.
Yeah.
So the same thing would hold if it's like u. So tell me, if I differentiate u to the 5, what I'll be? If I differentiate u to the 5, what I'll be?
5u.
Exactly, and we can differentiate u to the power 2 as well. U to the power 2, that'll be what?
2u.
Right, so here what we're gonna do, right? Here we're gonna do, in this case, we're gonna say, let u be equal to sine x. And Kiera, if u is equal to sine x, what would y be equal to? So again, I'm saying y is equal, let's say that again.
2.
Now be very careful. What do we say sine x was equal to?
U.
Okay, so I want you to look at this expression. If I replace sine x for u, what does the expression now become?
Y equals u.
Not just that, y is equal to u what?
2u. Oh no. U squared.
Yeah, because this is u now. This is just u, so u squared. Cool. And could I differentiate sine x and u squared?
Yeah.
Again, mission accomplished. You could differentiate both of them. That's good. So if I differentiate this, how am I gonna write the symbol for that? I'm differentiating what with respect to what here?
You're differentiating u with respect to x.
Yeah. If I differentiate sin x, what am I gonna get?
Minus
No.
cos x.
If you differentiate sin x, you just get cos x. If you differentiate cos x, you just get minus sin x.
Okay.
I know what you're thinking. Why it can't just be simple and both of
Yeah.
them just be positive? I don't know. Right? The next one now. If you differentiate in this, what are we?
2u.
Right, but you need to write the notation for that. What would the notation for that look like?
Y with respect to u.
Yeah. And that'll be 2u, like you said. Right? So let me apply the chain rule now. So dy dx, that's equal to dy du by du dx. Right, so Kira, tell me what to write. What is dy du?
2u.
So we have 2u by du dx. What's du dx?
Cos x.
Right, and we can't leave the u there. So remember, what was u? U is what?
Sin.
Right, so we're gonna write back that. So u is sin x. So I'm gonna write 2 sin x cos x. That's my answer.
Oh, okay.
Here, wait, Aliyah, have anything that confusing you? Anything you want me to go over?
No, I understand.
So again, typically whatever inside the brackets, that's what we just say u is equal to. That's basically the procedure. Most
Okay.
times. What's saying most times? Like 90% of the times. All the time. Right? Nicholas, you good?
Yeah, I got
All right. Kirsten, your message on let me know how you feeling. So I'm gonna give you all a question to do, and I wanna see the long working. I want you all to differentiate y is equal to cos squared x. Take a poke at that. Try to differentiate cos squared x using the long method. All right, so Amy, there. I'm gonna hear ma.
Yeah.
Amy, you do everything more or less correct, you know. But the one mistake you make is not writing out what v is. When you have v by du dx, you just said v was minus a half x. But that's not true. V is
Oh,
actually
oh my
sine
God.
minus a half x.
I can't believe I make that mistake.
Yeah, yeah.
Thank you. I didn't know I put a bracket, so I wouldn't get confused. Don't do that because I didn't know something like that.
Yeah, you still end up tying up yourself.
Okay, wait, I want to fix it now.
Yeah, but excellence. Right, so the rest of you, try to figure out the first derivative of cos squared x. All right, so Ali, are you there?
Yeah.
Okay, is it 2u minus sine x or 2u multiplied by minus sine x?
2 multiply. So
Right, so where's your brackets? So put brackets. Because right now, that looking like minus, and I wouldn't know, I don't know, I wouldn't know better.
okay.
So you need to put the 2u in brackets and the minus sine x in brackets to show that they're being multiplied. And then your final answer should be, think about it, you have 2 by a negative. 2 by a
So
negative. Right, so
minus
minus 2
cos x
sine x.
sin x. Okay.
Yeah, but not bad. Look, Nicholas, fix the mistake as well. He gonna write 2 cos x minus sine x. Nah, it's multiplication, right? So good job there, Nicholas. Nicholas, you see any shortcut method for this?
Believe I could see it.
So you take the power, multiply. So we put the 2 in front, right? Then you write back what was inside the brackets. So it was sine x inside the brackets. And then you differentiate that. So 2 sine x cos x. Real simple. For the cos squared x, right? It was 2 outside. It was the power 2. So you put 2 outside, right back cos x, and then I differentiate cos x. So I was supposed to get 2 cos x, well, minus 2 cos x sine x. This one's simple, real simple.
Yeah.
All right, Kira, I'm waiting on an answer from you. I'll make sure you can do this. Kira.
Hi, I almost finished.
Okay, cool. For those who finish with this question, I want you all to try this one. So I'm gonna spice things up a little bit. Let me see what they're gonna do. What if I said that is now t is equal to, I'm gonna change things up. 3 cos squared. Yeah, I want all to try to figure out the first derivative of this. Try something. Amy, I have it there. That's the correct answer for the question I gave you.
Okay.
Right? So everybody that's finished with y is equal to cos squared x, I want you all to move on to this question. Try to differentiate t is equal to 3 cos squared x. Now, Aliyah, would it be dy dx in this case?
No,
It would be what?
the TDX.
Yeah, the final answer should be dt dx. Nice. So while you guys are doing this question, trying to figure out this question, let me just put on the working for the y is equal to cos squared x. So you all are doing this question here, right? You want with the t. Try now. Okay, so if anybody that's confused, it's the same steps with the last one. We don't know how to differentiate cos squared x, right? Which is essentially the same thing as cos x squared. We don't really know how to do that. So what we need to do is we need to split it up into two functions that we could easily differentiate. So I could let u be equal to cos x. And if I'm saying that, then this whole thing inside the bracket becomes u. So now y is equal to u squared. In doing this, we end up with two expressions, certain expressions. We end up with two equations that are easily differentiable. So in this case, we have u, so we're going to differentiate the function u with respect to x. So if I differentiate cos x as minus sine x, and I have y with respect to u, so I'm going to differentiate y with respect to u. If I differentiate u squared, that's 2u. So to get back my answer, I'm going to multiply dy du by du dx. And that'll be dy du is 2u. So 2u by minus sine x. So the negative by the 2 is negative 2. We gotta recall what the u was. The u was cos x, right? Sine x. So the answer is minus 2 cos x sine x. Are you all getting through the try now question? Kira, did you figure out what to do?
I'm trying. Trying to
Try
process the
something.
question. So I trying some.
All right. Nicholas, that's wrong, eh? 3 cos squared x is not the same thing as 3 cos x squared. Then it would be 9 cos squared x.
I
Let me ask that question. Are you seeing any squared by the 3? Nah. Okay, so you said 3 cos x squared, right? That mean it doesn't that mean 3 cos x by 3 cos x?
yeah,
If I say that and any 3 go multiply to give me 9,
yeah,
so that's not equivalent to 3 cos squared x.
I
The only thing that's being squared there is the cos. Amy, excellent job. That's correct. Amy, you're bad. So in the exam, they're not gonna bring the same thing every year. They're gonna change up the question. All you need to know how to maneuver that. So, Alia, we have 3 cos squared x. What's the only term there that's being squared?
Cos.
Cos, right? So, and do we know how to differentiate cos squared x?
Yeah.
Yeah. So you shouldn't have much problem, right? You need to make a substitution. What is the substitution gonna be? You're gonna say u is equal to what again?
Cos x.
Right? And if u is equal to cos x, y would be equal to, well, not y. T would be
T
equal to
equal
what?
to
You
3
could do it.
squared.
No, not 3 squared. 3 squared is 9.
U
Remember,
squared.
3u squared, yes, because
So
the u,
yeah.
we're replacing the u for the whole cos x, so 3u
Right.
squared, right? So we're gonna end up with t is equal to 3u, t is equal to 3u squared.
Right.
Yeah,
And when you differentiate that, you get 6u, right?
correct. And that'll be, tell me what that'll be? Like the notation.
T. Wait. The differentiation of t with respect to u.
Yeah, so dt du,
Yeah.
right? And the other one you'll have u is equal to the cos x. You know how to differentiate that. So just put
Yes.
everything together and you'll get your answer. Nicholas, you get through?
Yeah, I send it now.
Okay. Right, so you have u is equal to cos x, you have t is equal to 3u squared. So that nice. dtx du dx dt du. Right, so that'll be 6u by minus sine x minus 6u sine x. Yeah, that's correct. Nice. Nice one. Nicholas, I don't know if you realize it, right? Bench, we differentiate cos squared x before,
Yeah,
and now we minus 2 cos x sine x.
yeah.
If I multiply that by 3 and talk get the answer.
I was thinking to do that, but you said we do long.
Yeah, really long. Oh, Aliyah, what happened to the minus sign? That should be. Oh no, I just blind. Sorry. I see it.
No, it there.
I
Yeah.
see it. It looked like it was part of the equal sign.
Oh, sorry. No, I tried to fit it in.
Is that dy over dx or du
No,
over
that's
dx?
du. That's du.
That's a very convincing y. I mean,
No,
that's a very
no.
convincing u.
It kinda high up.
It looked like a 4, to be honest.
I fix it.
Okay, cool. Well, excellent job. Nice. I'm happy to see that the variables are not confusing all that. Awesome. I just waited on an answer from Kiara, Kirsten. I think everybody else has an answer. Right, so Kiara, you could do this. You could figure this out.
I sending it no.
All right. Excellent job, Kiara. Excellent job. Well done. Kiara, you're making me feel bad by the emojis. You're making it sound like. Wait. Kiara, you there?
Yeah.
Nicholas, Kiara does still make you buy Subway cookies for her?
Yesterday about no, not yesterday, Tuesday I buy a whole Subway cookie.
Wait, Nicholas is say you're really grateful for Nicholas.
Yes, yes.
Yeah. Cool. So I want somebody to volunteer to help me explain this one. So who want to help me? Or who want to explain it? I would just write. Can I tell you? Who want to explain this? How much people volunteer Aliyah? Nobody. How much people volunteer Nicholas? Anybody
I
volunteer?
find so. I find so. Actually.
Okay, one for Nicholas. How much people feel we should volunteer Kiara?
Follow, take
I
care.
volunteered. I
I'm gonna buy
volunteered.
Subway cookies for you.
Wait, that is I hear Nicholas and I hear Aliyah. Okay, that's interesting. All those who want to volunteer, Amy. Okay, Kiara, then. Hey, Kiara. Cards are stacked up. The cards are not in your favor.
Alia, how could you do this to me?
I like how you explain it.
I cannot explain it.
You know, I like how you had explained it before.
I like how friends just convince friends to watch them feel.
No,
But
she's
I
not
know
gonna fail.
she's not gonna
Gonna
feel it.
fail.
She's not gonna feel it, but like until you know, okay, like let me just say one of your friends, they feel they can sing. And all they're all gassing them up, telling them, hey, go on America.
No, but they're so different.
And when they go on American Island and embarrass themselves, then but Kira not bad. Kira, you know what you do.
No,
You know what you do.
exactly.
And you need to work on explanations. You need to work on that. So let me do that one time. So Kira, walk me through the steps. What to do?
Okay, so T so basically it will just be equal. So T will be equal to 3 in brackets cos x and then squared outside.
Yeah.
And then so we let in u be the cos x, and well T would be equal to 3u squared.
Correct. Because we're saying this whole thing here is you, right?
Yeah.
Nice. Right. Tell me what to do next.
So since we let u be cos x, the French is a differentiation. We let in it will be du over dx.
So we differentiate in u.
Yeah, we differentiate in u, so it will be du over dx.
We differentiate in u with respect to x. Right? And
Yeah,
if I differentiate cos x, what am I gonna get?
you're gonna get minus sine x.
Nice. If I differentiate t is equal to 3u squared.
It will be you're differentiating t with respect to u, and it will be equal to 6u.
Okay, you're doing a good job explaining it. Nice. And what next?
So since we have dt, no, we're multiplying now.
Oh, why
So
am I fine?
because we had to find dt over dx.
How you
Yeah?
know we gotta find the t over the x?
Because
In the interrogator here. How you know we gotta find that?
well, t with respect to x and some so
Yeah.
right.
The original equation was t with respect to x.
Yeah.
Yeah. So gonna multiply. So
Yeah.
d
So it will be dt, well, d with respect to x equals du over dx multiplied by dt over du.
that's correct. Well done. I honestly find you explain it well. No, I'm not capping. I'm not gaslighting you. And who's the most delusional person in class?
Nicholas.
Whoa, 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 whoa. That was quick.
All right, all right.
That's insane.
I find that is real crazy.
That's just real crazy indeed. That just like that was premeditated or almost like she'd be thinking about on a daily.
She was waiting for that moment while she died.
Yeah. Right. So let me wrap up. Kira, what's the next step?
Oh. Okay, so since we have in brackets the minus sine x and the 6u, we have to put it will be equal to,
Everything here being multiplied. Everything there being multiplied.
yeah.
So
it will be minus 6 u sine x,
right?
and now it will be the last line, so it will be minus 6 cos
Yeah,
sine x.
that's correct. Nice. Nicely done. You deserve a clap, not gonna lie. They should probably give you a clap. You see the kind of friends you have? They volunteer and they even clap for you. That's crazy.
Ole and shame.
I don't know.
No, it was like a support thing, you know.
I see. That's some back support. All right. So we finished with trigs. Trigs should not give all the trouble anymore. We looked at all the cases for trigs. Now we're gonna move on to something that's very similar to this. We're gonna move on to crazy powers. Right? Okay. Right. Anybody needed to copy down the working? Taking those I know because everybody more or less sent me their working. I cannot see it. Right, so let me look at the other case now. I believe this is case 3. Now, case 3 is anytime you have like a square root or a surd or something. So like y is equal to the square root of 5x squared plus 2. So we have y is equal to the square root of 5x squared plus 2. All right, any suggestions? Amy, minus you. You know what to do already. Anybody else have a suggestion as to how to move forward? Alia, you know how to move forward?
No, I don't think so.
Come now, man. In differentiation, everything has to be written as a power, like to a power. What power is this square root?
2, so you could remove the square root sign and put the whole function in brackets and square it.
Square it. No.
No,
Square and square root opposites actually
you could put it
to the power. Power. What is this? What power is square root?
2.
Okay. So you are saying that the square root of 16 is the same thing as 16 squared.
No, it's like
It's not 6. It's not squared. Opposite that 2. What's the opposite of 2? Like, okay, what's the opposite of multiplying something by 2? What's the opposite of making something?
Divided.
Yeah. Yeah, so it will be a half. So the second line should be y is equal to 5x squared plus 2.
to the power half.
Now, all you know what is going. All you know what is going, right?
Yeah.
What we're going to say u is equal to.
U is equal to 5x squared plus 2.
Right. It's always be inside the thing inside the brackets, right? And if we say u is equal to
Yeah.
5x squared plus 2, what are we going to say? Y is equal to, Kiara? Y is equal to what? What? Oh, it will just be a half.
It would be u to the power of a half.
Yeah, because u. So this watch. Now it will be y is equal to u. Because replacing, and we say now this is u. Kiara?
Yeah, we are.
So then it'll be y is equal to u to the power of half. No, someone there was like, and I could just expand this. Kira, do you know how to expand something that's to the power of half? No.
Probably
Wait,
no.
probably. And you real good. You know about Taylor series.
I'm not real good. I can't do it. No, we can't.
All right. What if it was to the power of 2 and to look at that expander? Like 5x squared plus 2 by to the power of 2. And we can expand that. Kira, can we expand that? Like if it was 5x squared plus 2 to the power of 2.
Yes.
Yeah, that just means 5x squared plus 2 by itself. And then we know how to do binomial expansion. Let's look at that expander.
Yeah, we can.
Yeah, but if it's to the power of half, you can't do anything. Can't do nothing. So we need to come up with these with a substitution. So we decide to say, okay, let u be equal to 5x squared plus 2. So if u is equal to that, then y is equal to u to the power of half. Kira, can we differentiate both of these terms easily?
Yes.
Yes. So I'm gonna call upon Nicholas to help me here. Nicholas, differentiate this for me.
Alright, 10x. No, wait. Yeah, just 10.
Right, so you'll be some notation too, eh? So do you
Alright,
like 10x? And what is could be?
that would be
D what?
dy over dy.
Right? Are we equal to?
U over 2.
No. When you're differentiating, you're taking the power, multiplying it by the number in front, then you're minusing 1 from the power, right?
Yeah.
So that'll be a half u to what power?
Minus 3 over 2.
3 over 2. Now, where's a half minus 1?
Half minus 1.
It was a half minus 1.
Minus a half.
Minus a half, that's correct. Cool. So we have all the parts we need. Right? So now we go into use the chain rule to combine them. So dy dx and dy dx will be equal to
du dx
right, du dx.
multiply by dy over du.
Right? So nice. Now we're gonna combine the two rates of change. So du dx is 10x, and what is dy du?
A half u to the power minus a half.
Right. Now everything here is being multiplied. So we could say 10 by a half. What's 10 by a half?
5.
5. So we have 5x. And that's being multiplied by u to the power minus a half. Now we need to recall what u was. What did we say u was?
U was 5x squared plus 2.
Right. That's it. Now if you wanted to do more working, you could have said 5x all over the square root of 5x squared plus 2. If anybody don't know how I jumped to that line, let me know. Nicholas, you know how I jump from this line to this line?
Yeah, I know how.
Explain. How did I jump from that line to that line?
3 minus a half on the power. That the whole reason you put 5x squared plus 2 in the denominator and square rooted. Because because it have the minus a half there, you put it on the denominator and the a half means just the square rooted.
Exactly. Anytime you have a negative power, that means it will be positive on the other side. So if it's negative in the numerator, it'll be positive in the denominator, vice versa. And when I move it here, it will just be a half. And a half is just square root. So that's it. Anybody confused by this? Let me know, guys. After you all have that copy down, I want you guys to try this one. So y is equal to the cube root. I know it sounds complicated, but it really isn't. So y is equal to the cube root of 7x plus 1. So Kira, are we good? Tell me if you understand that little magic trick I do over here. I went from the minus half to the fraction. Kira, are we?
Yes.
You
But
know
I
you
was trying
carefully.
to unmute. My touchpad was sticking, but yeah.
All right. So if it was to the power just a half, would I have to move it to the bottom? If it was to the power positive a half, would I have to move it to the bottom?
No.
No, because it's already positive. The only reason I move negative a half to the denominator is because it was negative. If you have a negative power, think of it like this. It's unhappy in the numerator, so it will go to the denominator to be happy. So it's negative in the numerator. If you move it to the denominator, it'll become positive. And Kira, if you have something raised to the power positive a half, that's the same thing as doing what's it? Like if I have 16 to the power a half, that's the same thing as what? That's the same thing as doing what to 16?
16. This square.
Square root of 16, yes.
Okay.
Yeah, have it there. Square root of 16. So try question 2 by yourselves. You need to know the shortcut method for this. So I'll go over that. I'll go over the shortcut method after question 2.
That's cube root, huh?
Yeah, that's cube root. So cube root means what power then?
Oh, a third.
Yes. Now they don't have to bring cube roots, they can bring like 4 over 3, 7 over 9, all kind of thing. They can really do whatever they want.
Yeah, because of wicked.
Yeah. Very good. Okay. Are you getting through with question 2?
Yeah.
Okay, nice. Alia, what about you? Are you getting through with question 2?
Yeah, I almost finished.
Amy. Ooh, you make a little mistake. Amy, if we differentiate 7x plus 1, what do we get? Oh, so you wrote 7x. But to write back 7x meant that it wouldn't have been changed.
Oh, 7.
7, yes.
Okay.
Oh, Amy, a little mind experiment here. I'm gonna show you something cool, right? If you have y is equal to 7x, and y is changing by 7 times x, so the rate of change is 7,
Yeah.
think about that. Whatever you put in for x is going to change by 7 times, and that'll dictate what y is. So that's why the rate of change is 7.
Okay.
All right, Nicholas, let me see what you have here. Nicholas, I have a question, right? Is a third minus 1 minus a third? I should probably check back that. Is
Alright.
a third minus 1 minus a third. All right, Amy, let me see what we have here. So 7 u to the power a third as a third u minus 2 thirds. Divide du minus 7 over 3. Yeah, Amy, that's perfect. That's a perfect answer. Nice. And you apply thirds and everything. All right, so Aliyah, you're playing it safe for sure. Now I need it to be a little more risky. You have 7x plus 1 to the power minus 2 thirds. Since it's a negative power, and it's in the numerator right now, where will it be positive?
At when is the denominator?
Right, so that's by the 7 or by the 3?
By the 3.
Right. So it'll be 7 over 3 by 7x plus 1 to the power 2 thirds. And then you need to recognize that if you have something to the power 2 thirds, watch, if I have x to the power 2 thirds, that's really the same thing as x to the power a third squared, or is the same thing as x squared to the power a third. Tell me that makes sense. X squared,
Yeah.
when you raise
Yeah.
up a power, you just multiply.
Yeah.
Okay, so then, and I could write that as the cube root of x squared.
Yeah.
Sure. So, if I have x to the power 2 thirds, I could write that as x squared to the power a third. So, cube root of x squared. So, it's the same thing we're going to do over here, right? We have 7x plus 1 to the power 2 thirds. That's the same thing as 7x plus 1 all squared to the power a third. We know a third is cube root, so that'll be 7x plus 1 squared. You catch?
Yeah.
Nice. Or Amy, I see another mistake. Amy there?
Oh, yeah.
Yeah, so you said 7u plus 1. So it'd be 7x plus 1. Check your answer. Check your final answer. You have 7u plus 1.
Oh, okay. Yeah.
Right? Yeah, Aliyah, that's correct. Nice. Nicholas. Nicholas is not entirely correct. Right? Nicholas, if I have 7 over 3, right? And I have 7x plus 1 to the power minus 2/3. That's the same thing as 7 over 3 multiplied by 1 all over 7x plus 1 to the power 2/3. If you remember standard 5 maths, numerator by numerator, denominator by denominator. So this will be 7 by 1 is 7, 3 by 7x plus 1 to the power 2/3. So the 7x plus 1 really supposed to be by the 3. The 3. Like you have 7 over 3. It's supposed to be by the denominator.
All right.
Nicholas, I'm gonna explain that one more time. Right? So we have, I'm gonna take it simple, right? You have 7 over 3. U to the power minus. It's supposed to change that to minus 2/3. You have 7 over 3, u to the power minus 1 over 3. That's supposed to be 7 over 3, u to the power minus 2/3. That is the line after, as 2 lines after dy dx. You have 7u to the power minus a third.
Yeah, I seen.
Right? So imagine you have 7 over 3, u to the power minus 2/3. And so I could write that as 7 over 3 multiplied by 1 over u to the power 2/3.
Yeah.
Right. So then the top would multiply by the top with 7 by 1. 7. And the 3 would multiply by the u. So that'll be 3u to the power 2/3. So you notice it is with the 3. Watch, like u to the power 2/3 is in the denominator with the 3.
Yeah.
Yours is different because you have 7 over 3 all over the cube root of that. So it's different.
All right. Yeah, I'm gonna change it.
Oh my God. So I'm gonna send Aliyah answer in the chat. Aliyah answer was good. Right, so I'm gonna do this question on the board, right? So first things first, we're gonna change the notation. Instead of writing cube root, we're gonna write it as a power. So I'll say 7x plus 1 to the power a third. Then I'm gonna say let u be equal to whatever's on the inside. I'm gonna differentiate that one time. So that's gonna be du dx, which should be equal to 7. Right? If I'm saying u is equal to 7x plus 1, that means y would be equal to u to the power a third. And if I differentiate y with respect to u, I have to multiply by the power. So a third would come in front. And then I would minus 1 from the power. Nicholas, what is 1 minus a third?
Minus 2/3.
Right? Minus 2/3. Cool. Right, so the fine for dy dx, that would be equal to the dy du by du dx. Dy du is a third u to the power minus 2/3 multiplied by 7. So Nicholas, be very careful here, right? So let's observe. So Nicholas, u to the power minus 2/3 is the same thing as 1 over
1 over u power
say that again?
u to the power 2/3.
Yeah. So wait to observe what's happening here. When you plug in what u is, when you multiply this out, wouldn't it be 3 by this?
Yeah.
Right. So let's let's multiply here. 1 by 1 by 7 is 7. 3 by u to the power 2/3. That is 3u to the power 2/3. Now this is why I might lose some people, right? Now, if I have u to the power 2/3, that is the exact same thing as u squared to the power a third. Because a power to a power means multiplication. So, Nicholas, if this is the case, I could write this expression as what? What could I write that expression as?
The cube root of cube root of u squared.
Yeah,
That's
that's
it.
it. That's
That's
it.
it. Yeah.
Right? Because watch, you have u squared in brackets raised to the power a third, which means cube root. And well, you have u squared. So that's exactly what we're gonna do. So it'll be 3 cube root u squared. And now that we have it simplified as much as possible, and we can't do anything further, now I'm going to write back what u was. Right? So at the start, I said u was equal to 7x plus 1. So that's that. Yeah. So in the interest of time, I want to do one more case, but I'm going to speed through that case. And it's really a simple case. So the last case we're going to look at is if we have like a expression raised to a crazy weird power that don't make sense to expand. Like, Nicholas, you feel it would make sense for you to expand this thing 17 times? You think you will finish?
Me personally, I could do it, but
Right. It's not like it's a skill issue. It's not a skill issue. You just take too much time.
yeah.
Yeah, so there's a smarter way to do this. Can we recognize is more or less the same thing as what? If I had to differentiate something like this, doesn't it look almost exact like that?
Yeah.
Yeah, watch. Both of them raised to a power. And this is a very unreasonable power because to the power 17, you can't expand that. So the steps are going to be exact. To differentiate something like this, the steps are going to be exact. You're going to say, are you hearing the funeral person? You have a funeral person. Are you hearing it?
Yeah.
Yeah, so we're going to say let u be equal to 9x plus 7. And we would say y is equal to u to the power 17. I'd like to tell you the exact same steps. Right? Differentiate this, that'll be du dx. That'll be equal to 9. If I differentiate this, that's dy du. Nicholas, differentiate that for me.
That's 17u
To what power?
power 16.
We don't have any funny business with negative or fractional powers, so we're good. Right? So to get dy dx, it's just a simple matter. It's just a simple matter of saying dy du by du dx. So that'll be equal to 17u to the power 16 multiplied by 9. Right? So Nicholas, what is 17 by 9?
17 by 9.
Yeah.
17 by 9, 153.
Wanna know how I can do that in my head?
I cannot do that in my head.
Okay, watch this, right? Look how I would do this. 20 by 9 is 180. Right? 17 is 3 less than 20. So I will say 3 by 9 is 27. And in my head, I would just subtract those 20 and get the answer. So 153. That's what I would do that in my head. Yeah.
Well,
Over time, it just become normal. Like, easy. Right? So 153. And we said u is 9x plus 7. So 9x plus 7. Yeah. The shortcut method for this is very easy. All I have to do is just take the power, put it in front, differentiate the inside, write back the original thing, and take away 1 from the power. That's all. Very, very simple. Matter of fact, it's the same shortcut for case 3 as well, because it's the same situation. You have a power. So next class, I will go over the shortcut. We'll do some questions, and then we'll move on to rates of change, which uses the chain rule. Right? So everybody all right? I will send the notes immediately. But you all okay?
yeah,
All right.
I good.
Kiara, Aliyah, Kirsten.
Yeah.
Hi.
Are you good?
Yeah.
Yep.
All right. Well, I'll see some of you Wednesday, see some of you Friday, and well, so on and so forth. So, and Amy, I will see you tomorrow. So later, everybody. Thanks for coming to class today. Well, enjoy
Bye.
the Sunday.
Bye.
It's
It's Saturday. Later, everybody.
yeah, it's